session, we are going to learn about the third chapter of mathematics, which is pair of linear equations in two variables. So first of all, let's recall what you are aware about this linear equation, right? So linear equation deals with the degree of polynomial, which is 1. Let's recall linear equation in one variable first of all. So let's take an example of 2x plus 3 is equal to 7. We want to find the value of x such that LHS and RHS is equal. Let's do that. First of all, I will be shifting 3. So that will make 7 and the sign will be changed here, which will be minus 3. 2x is equal to 4 and let's get the final value of x, which is 4 divided by 2 and 2. So the final value of x is 2. Now let's verify LHS and RHS. So let me take LHS is equal to 2x plus 3 and I am going to substitute the value of 2 in this equation, which is 2 into 2 plus 3, 4 plus 3, and the final answer is 7. You can see that is the same value given on right hand side. So let's present the same solution on graph. So let's represent the same solution, which is value of x is equal to 2 on the graph. So we need to take x is equal to 2. That's our final solution. So you can see on x-axis that 2 is over here. So I am going to draw one straight line. That is the solution of this equation. Now let's come back. What did you learn in grade 9? In grade 9, you learn about the equations in two variables. Let's take an example of it. X plus y is equal to 2, right? You did not learn how to solve these equations, but you had many combinations of the equations. So let's make combinations of it. So first of all, final answer we need to get as a 2. So let me take x is equal to 0. If I take x is equal to 0, it makes sense that 0 plus y is equal to 2. That will give me y is equal to 2. So my first coordinates are x is equal to 0 and y is equal to 2. Let me substitute over here. X is equal to 0 and y is equal to 2. Let's find the another solution. Now this time I am going to take y is equal to 0. Okay, so x as it is plus value of y 0, that is, and the RHS as it is 2. So it makes sense that x is equal to 2. So let me substitute the same. The second coordinates are 2 and y is equal to 0. So 2 and y is equal to 0. Now I am going to represent the same solution on graph like we did over here for the one variable. Let's do the same for two variables. So right now I am having two coordinates that I need to represent. So first is 0 and 2. X is equal to 0 where y is 2. So this is the point I am interested in. Let's represent the second point. X is equal to 2 and y is 0. That point will come on x-axis, which is here. Now we are going to draw a straight line connecting both points. So when we represent a linear equation in two variables, it will look like a straight line, and we need minimum 2 points to draw a line, not like only 1 point, which we did in case of one variable. So this is the conclusion. We need minimum 2 points, but here in case of one variable, it is only single point. It is very evident from the answer itself. So in this chapter, we are going to learn about how to find the solution when we are having two different equations. So in this session you learn about what you already learned in grade 8 and grade 9, linear equation in one variable and linear equation in two variable. What is the solution if it satisfies LHS and RHS? That particular point is called as a solution of equation. So let's talk about the case of two equations. When we have two equations, we are going to have two lines on graph paper. So let's talk about that. What are the three possibilities? Let's talk about the first possibility, that maybe, let me take this one line and this is another one. So you can see this is the intersecting point. Both lines are intersecting at one point. Let's talk about the another case. In this case you can see that both lines are parallel. They are not having any kind of common point where they can intersect each other. Let's talk about the third case. Where lines are lying on each other, right? This case is called as a coincident. So we are having three cases. One is about intersecting lines, another is parallel lines, another is coincident lines. What we are interested in this chapter to learn the nature of two equations. Either they are intersecting, either they are parallel, or either they are coincident lines. When we talk about the parallel lines, obviously we are not going to have any kind of intersecting point. But this is the first important case where we are going to have intersecting point. So we are interested in the nature of lines. Either they are intersecting, either they are parallel, or either they are coincident lines. So let's start with the next topic, meaning of solution of equations. Okay, most of the times you have read a sentence, find the solution of equations, but what does it mean? So let's start the concept of meaning of it. Let's take an example of two equations, which is x minus 2y is equal to 1 and another is x minus y is equal to 1, right? So again we are going to find the different coordinates for this each of the equations, right? Let me make a table for it. Y and x, same here. Y and x. Now I am going to take two different values of y. So first I will take 0, then I will take 1. I will do the same in this case. So if I take the value of y in this case as 0, so it will be x minus 0 will be 1. So I will get x is equal to 1. Let me write over here. Let me take y is equal to 1 over here. So x minus 1, that is 1 over here, and if I shift that side, that will make 1 plus 1, 2. So the solution is 2. Let me do the same procedure for another equation. Y is equal to 0, x minus 2 into 0. So anything you multiply with 0, obviously you are going to get as 0. So x is equal to 1 over here, and let me substitute another one, which is y is equal to 1, x minus 2 into 1 is equal to 1, and if I get the answer of this one, that will make x is equal to 3. So when we talk about the solution of the equation, we want to find what is the intersecting point. Intersecting point means what? What is the common point between this line and this line? So you can see from this table, there is a one common point between both of this line, which is 0 and 1, and same goes over here as well, 0 and 1. So this is the solution of these two equation. They are having one point as a common between them, and this point is called as intersecting point. So when I represent both of the lines on graph paper, they are going to meet at what point, which is 0 and 1.